So in the last two sessions, we discussed about string methods and also we have seen some programs on strings and also arrays. And we have seen some interesting topics on string, how string works in Java, right? And yeah, now from this session, we are gonna learn OOP concepts, that is object-oriented programming concepts. So if you remember in the first session or the second session, we have discussed about Java. When we were discussing about Java, we discussed about Java is an object-oriented programming language. So Java is an object-oriented programming language because Java supports some concepts, some object-oriented programming concepts. All these are object-oriented programming concepts, and Java supports all of this. So we can say Java is purely object-oriented programming language. So class, object, polymorphism, encapsulation, inheritance, and data abstraction. All these are the object-oriented programming concepts. So in this session, we'll discuss about class and object. So we'll discuss about all these concepts in detail. And in this session, we'll concentrate on class and object. So what is a class? So without a class, we can't write a Java program. This we have seen in the last sessions, right? So we first create a class to write a Java program, right? But what is a class? How can we define a class? Is so in Java, a class is a collection of properties and functionalities. So a class can be defined as a collection of properties. So we can even say attributes and properties and functionalities. We can call this as methods. So class is a collection of properties, which we can call it as attributes to store data and functionalities. We can say call that as methods. So to actually showcase the behavior of the particular class or behavior of that particular class, right? So that is how we can define a class as. So what is the syntax of a class? So class, it can have some attributes, class name, class, class name, and then we can have properties. So properties or attributes are one and the same. These are nothing but the variables. So whatever we discussed earlier, so we call them as variables, right? So we can call it as variables as well. We can even call this as data members. All are same. So class contains just you can remember one at least, like let's say properties. Class has its properties or attributes, and also class will have methods. So why methods is methods we can use these properties, and we can either use these properties or not, but methods represent the behavior of the objects defined on class. So we haven't come up to the objects, but just think of stuff like it actually showcases the behavior of this class, right? So properties are used to store the data or information which is related to that class, and method shows the behavior or functionality of that class. So that's how we can define a class as. So this is the reason we are defining a class is a collection of properties and functionalities together is a class, right? So what are the so let's actually learn the what are the features of class or the characteristics of a class. So a class is a collection of fields, right? Or attributes or data members, anything we can call, and methods, right? That's a definition. And a class describes the behavior of an object. It actually describes the behavior of an object. So once you look at the class, you can say what's the behavior of an object. So it's not, it's a logical entity. It's a blueprint. It's not the as actual physical entity. So it's just a logical entity. It's like a kind of blueprint. And a class will not occupy space in the memory. It's as it's just a logical entity, it doesn't occupy space in the memory. So it's just a logical entity, right? A classical examples of class are, so a class, we can say, a car is a class. A car can be a class. So how can we say a car is a class? So car has some properties like, you know, car has color, right? Car has color, model. A car can have color, type, and model, right? So these are the attributes of a car. And what are the methods? Meaning, what is the behavior of a class, right? So this we can call it as attributes, and behavior we can say like accelerate is one functionality. So we always enclose method within it, with the brackets, right? Accelerate, and break. Break can be one method. Take left turn, and so on. These are the behavior of the car, right? So we can call a car as one class. These are methods. These are the attributes, right? So in the same way, like we can have another example as book, right? So a book is a class. We can say book is a class. Book will have its name, author. These are all the author, you know, genre. We can call it as title even, right? So these are all the properties of a book, right? So likewise, so we can have like any other example, like product. Product is one class. Product will have product name, right? Product price, product type even. These are all the properties of a product, right? So, and so if you see, car is one class and book is one another class, because everything, if you see, these are all like a type, type, and each have its own properties and each have its own functionalities, right? So these are all some classic examples of what a class is in Java. So you can consider even student. Student is a class, right? Student can have student ID, name, marks, grade. All these are the properties of a student, right? So student is one example of a class. So these are all the examples of a class in Java, right? So you just need to know that a class is a collection of properties and methods. So a class is a collection of properties and methods. Methods in the sense behavior, which in within you use methods to actually showcase the behavior of the object of that class, right? So this is all about a class in Java. Now let us see object. What an object is. So object is an instance of a class. What is an object? Object is an instance of a class. What do we mean by that? So object is an instance of a class in the sense. So if we have a class is a blueprint is what we said, right? It's just a blueprint. It's a logical entity. So it's not a physical, it's a logical entity. So it doesn't, have any meaning on its own, but it will have a meaning when we create an object on the top of the class. Like, so that's what we call it as an object is an instance of a class. So when we create an object, for a class, then that becomes the actual usable entity. So we can call it as a physical entity. For example, so an object of, so say for example, an object of product can be, so say for example, a product is a class is what we said, right? So the objects of a product could be anything, right? So it can take a refrigerator. Refrigerator is a product, right? So this becomes a object of the product. Air conditioner is one product, washing machine, and so on, right? So they're all the products. So product is a is a class. If you consider product as a class, what will be the object? Object is an instance of a class. So all these could be an objects of the class, right? This is an example, right? So now we'll see the characteristics of an object. So object is an instance of a class and object is a physical entity. So we create object, taking class as the base. We'll see how we create an object for a class, and class gets a meaning only when we create an object on top of it. So object, we can consider it as this is the actual physical entity. So class is just a blueprint, object is a physical entity. So as object is a physical entity, it occupies space in memory. So when we discussed about class, what did we say? We said it's a logical entity. Class is a logical entity or blueprint which will not occupy space in the memory. But object is a physical entity which occupies space in memory. And we can create multiple objects for a class. We can have one class and we can create multiple objects for the class, right? So this is all about the object. Now, how do we actually create an object? So say, for example, a class. A class is already there, right? So using the class, we can create the object, right? So a class is just a logical entity. It gives us a blueprint. And using the class, we can create the object. So when we create the object for the class, that becomes the actual physical entity, right? So we can think it of like this, right? So say for example, you have some house, right? This house. First, before constructing the house, we'll be having some blueprint, right? We'll be having some plan. So that you'll put it on a paper. Your plan will be on a paper. So this will be the house planning. What we call this as, this will be blueprint. This is not the actual house, but it's a blueprint, right? It's a blueprint. So say for example, looking at this plan, we construct the houses. So same plan can have multiple objects, multiple houses, the actual physical entities, right? So we can say house one, based on this design or plan, we can construct the houses. Number of houses we can construct, right? So in this example, like we can consider house plan as a class. So if you see, this is not the actual class, actual house, right? This is just the blueprint of the house. This is how we wanted the house to be, but this is not the actual house. It doesn't have any meaning to it. But without this plan, you can't create you can't actually construct the house, right? So this is giving you the idea how to construct the house. The actual house is constructed, right? So these becomes the actual objects. So these represent the physical entities. These are the actual physical entities, right? So physical entity is where we can touch and feel it, right? So this is what we call it as a physical entity, and the actual houses constructed are called as objects in this example, right? So the blueprint, the plan, house plan is a class, and actually constructed houses becomes the physical entities which are objects. So this is how you can understand a class and a object. Is that clear? So let's take an example and understand. So let me take an example. We'll create a new package for today. I'll call my package as detail. We'll create a class within it. I'll call my class as employee. Employee could be one class. Till now, what we used to do? We used to declare variables, initialize them in the main method because we know the execution starts from main method, right? Now, we are going to define the properties, that is variables within the class. So how do we do that? Like how we actually declare a normal usual variables, right? So in the same way, we declare the variables for the class as well. So say for example, I'll declare what would be the properties of an employee. An employee could have an employee ID. An employee can have an employee name, right? So, and also employee could have a position. So position in the sense, we can say it as job position, right? So we can say just job, and an employee can have salary, right? All these are the properties of an employee. So what did we say? So we'll come to this, what public is. So these are called as access modifiers, and we'll discuss about this in more in detail in the coming sessions. But just for now, say for example, class, a class name, and then within the parentheses we have like properties and methods. Main is also one of the method, but that's a special kind of method, right? We know execution to start execution. So we need main method. JVM looks for the main method and the syntax has to be this way. So the execution starts from here. So for now, just leave about the main method. So every class, it has its own properties or variables and it will have its own methods as well. So it should have methods, right? So what could be the methods? Say for example, display employee details. This is one method. So as said, method will always be followed by a braces. So these braces could be empty or it could even take the parameters. Parameters in the sense it will have some data within it. And this data can be used within the methods. So again, the syntax of the method, you can see here, method name and, followed by brackets. And within the brackets, it can take parameters. We'll see that in the next session, how a method takes parameters and how we are going to use those methods, how we are going to use those parameters within the methods. But for now, just think it of like, so to represent a method, we use this brackets after the method name, right? And a method is enclosed again, like within a curly brace, starting curly brace, and closing curly brace, right? Open and closing curly brace. So this is a method, and we usually write a method to perform some task or to show some behavior of the class. This is what we discussed, right? So, and if the method is not returning anything, so usually methods could return something or it could not return also. So it can return something or return nothing, right? So depending on that, we actually define the signature of the method. Signature of the method in the sense, like if the method is returning something, so you write some logic, some block of code within the method. And finally, if you wanted to return something, right? So we actually we can return something, right? That something could be of some data type. That data type has to be declared here before the method name. Now, if the method is not going to return anything, so in some cases, you might have a method defined, but you might not be interested to return anything. You just wanted a method to be defined and perform a simple task and come out of that method, right? So in such cases, will not have the return type for the method, right? In such cases, we have to mention the return type for the method as void. So usually we write some statements here, and then we can return something, right? Return, and then we can return some variable, which could be of any data type, right? And if you are returning something of some data, some information, some data here, so that return data type, we have to specify it before the method name. And if I don't have any return, so say for example, I'm not returning anything, then in that case, we have to specify void. This is a keyword in Java. We have to specify void before method name, which indicates that this method is not returning anything. It is defined just to have some logic written within it. And so once this method is called by someone, some object, then the logic within it or the block of code within it will be executed. That's all. It is not going to return anything. So that's the meaning of void, right? Now, for our example, we wanted to display employee details. We do have the employee properties defined here, right? So that we wanted to display it here. So how do we display it? We display employee ID, employee name. We wanted to display job and salary. Salary could be in decimals, right? So that the reason I have declared it as a double. So now what did we do? We had a class here called employee, and employee class could have some properties. We have defined that. And a class can have some methods. So we just for simplicity, we have defined one method in it. So a class has a properties and a method now. So this method, what it is doing, it is just displaying the employee details within it. Now, where do we get this data? Get the data for this class? Usually, what we used to do, we used to define some information. We used to initialize some value to the variables like this. And if we do system.out.println of employee, we know that 10 will be displayed on the console, right? But now we are not initializing any value, but still we are trying to display the employee details, right? So this is because a class is just a logical entity. It doesn't have, it in its own, it doesn't have any meaning, but it's a blueprint. It's a blueprint to create the objects, right? So, say for example, if I define something like this, right? Employee ID equal to 101. This is a class, right? Now, I create an object on top of this class. Now, we are going to do that, right? So, employee one could be, so I'll create one object called employee one, like how we did for house, right? So taking one plan, so we can have multiple houses. In the same way, I had one class called employee, right? Now I can create multiple objects on top of this employee. Say for example, employee one. Employee one will have its own properties, meaning so the same properties, but the values of it will be different, right? So employee one could have 101 and his name could be something, job and salary. See, in the same way, like employee 2 will have some properties, right? So, but they might not have the same. All the employees will usually not have the same employee ID, right? So, this is the reason we are not defining any value to the variables at the class level. If you define the values at the class level, then even though if you create an object, the object will be like created on top of class, right? Using the class. So that object will have this value already. So any object you create for the employee, right, will have only this property, right? This is, but that is not what we are interested in. We wanted to create the objects on top of the class and provide the values for each object independently. Like each object is independent to itself, and each object takes the values of its own on top of the class, right? So that is what we are interested in. These are the properties, and this is the method which shows the behavior of this class called employee, right? Now let us see how to define an objects. So this is all about the class. It's just a blueprint. We have said these are the properties of an employee and these are the methods. This is a method which we wanted to show the behavior of this class called employee. Now we'll define an object of the class called employee, right? So how do you define an objects? So employee, we have to say employee, the class name, and then an object name followed by an object name new. New is a keyword here, employee. So this is the syntax for creating an object. So when we say new employee, then what happens is an object gets created in the memory. So some space will be reserved in memory and an object gets created in the memory. Till now, when we create class, no memory will be occupied, right? So there is no space in memory allocated for this class called employee. But once you define this object called emp1, right? In this case, so then, or just for now, just forget about this. So when we say new employee, right? So meaning I wanted to create an object for employee class is what we are seeing. And for this, we are saying new. When we say new, some space, right, for employee object will be allocated in the memory. So when we say it's a class, so we define a class. So this is employee. This is fine. But what we wanted to do, we wanted to actually define an object for this employee, right? So when we say employee object, so this is an employee class. Now we are creating employee objects. So when we say new employee, right? So an object gets created in the memory like this. When we say new employee, an object gets created in the memory. Now, for this object, as this is an object, physical object, it needs some space, right? So as it needs some space will be allocated in memory. But how do we know how much space it requires? So that is defined by the class. So we know these are the properties of the class, right? So now this object will have its own properties. All these properties will, so this object will have all these properties as well as this method within it. So let me show you again. We had a class, right? So this we can call it as a employee class. Now we'll have this. This is just a blueprint. Now using this class, we are gonna create some objects, right? So that objects could be like this. Say for example, this is object one. This is object two. Object three, like this. This could be employee one, employee two, employee three. Each employee will have its own information. So each employee will have its own employee ID, employee name, job, salary, like that, right? So we can have multiple objects defined using the class, right? So when we create a separate object, then actual space will be allocated in the memory by JVM for each object. Only when we create the object, space will be allocated in memory. Till the point, we don't create the object, no space is allocated as there is only a blueprint. Employee is a class, which is a blueprint, will not occupy space in the memory. But once we create the object for that class, then space will be allocated in the memory. Why we need spaces? In order to store these properties as well as this class. So every object will have its own properties. So and the methods within it, right? So it will have its own properties as well as its own methods. So say for example, this will have its own properties. Properties in the sense, in this case, employee ID, name, job, and salary, right? And method, its own copy of method, properties and methods, right? So same is the case for any other object as well. So once we define an object, it will have its own properties and it will have its own methods. So its own copy. Each employee will have its own copy, right? That's the reason some space is allocated in memory for each object. Now coming to this point, like how do we actually create an object? So we create an object using new keyword, and then we need to specify the class name, and then followed by braces again. So you should not get confused this braces with a method, right? So even while creating the object, we use this braces, but before the class name, when we say new, a new object of this class will be created in memory. Now, in order to hold this, so when we discussed this in the last session, when we create an object in memory, so it will have some reference, right? So it will be stored in memory and it will have some location, memory location, which we call it as a reference, or which we call it as reference, right? So that reference we wanted to store it in some variable or some object, right? So this is an object and we wanted to store it at some place. So this is of employee type, right? New employee. So when we say new employee, an employee object got created, right? So that reference we wanted to store it somewhere. So we'll create employee emp1, right? So to store this object, because this is of type employee, right? So this is the reason we have declared, like it's like a variable, right? So when we say 10, that's an integer variable, and we can store it in by declaring a variable called a and of type int, right? So in the same way, new employee is an object. An object is getting created. So it's an object, right? So we have to, so in order to assign it or hold it, we need to declare the type of it. So we declare the type which is written by this object, that is employee, and we have to provide some variable name, right? So here we call it as object. So instead of variable name, we call it as an object because we are not creating a data type of a normal primitive data type, right? So we are created a class and we wanted to create an object for that, right? So here we created the object and we are actually holding that in a reference. We wanted to hold this object in a reference. So that's the reason we created a employee reference here, right? So this we can call it as object as well, because this itself is holding the object, right? So emp1 is one object here. So this is the syntax how we define it, how we declare and define an object. So once we create emp1 as new employee, some separate space will be allocated in memory for this object called emp1. And emp1, as it's a separate object of class employee, it will have its own copy of properties and methods. Now we will actually provide the data to it. So emp1 dot, if you say emp1 is representing the class now. So it will get all the properties and methods of employee class, right? So if you say dot, you can see those properties as well. So it has employee ID, employee name, job, salary, and right. And also you can see followed by its data type. It is showing followed by its data type and which class it is coming from, right? So and also it has and also it has display employee details, right? So which is returning nothing. So it is showing the return type as void. It is coming from employee class, right? So these are all the properties and this is a method we can use, right? So when you say dot employee ID, select employee ID equal to, say for example, it could be some 10. 10 is my employee ID, or say for example, 101 is my employee ID, right? emp1, emp1 dot, I wanted to provide emp name. I'll just say Kevin. Job. Say for example, programmer or developer. Salary is double value. So we can provide some value here. So we are providing some data using the objects. If you observe, we created a class and we created an object for the class. So some space will be allocated for this object. So as the space is allocated already and an object has been created, we are passing or we are storing data using the objects. Using the object, we are accessing the data members or attributes of the class and we are assigning data to it. So this is specific to that particular employee one, right? The data is specific to that employee and method as well. So emp1 dot display employee details. So as emp1 is an object, so which is actually having all these properties, and this emp1 is specific to this, right? Like this emp1 object itself is holding this data now, right? And it has its own copy of method as well, right? So you can see it is calling its own method now. So this method, what it has to do, as EMP1 already holds this data, now it is saying it is calling its own method. Calling in the sense like it will when we wanted to call a method, so object dot method name, right? So then what happens is this method will be called and execution will be going here, right? And it will start executing this statement, right? So in our case, so we have created an object for the class employee and assigned some data to it, right? And then we are actually calling the method. So method, what it has to do, it has to display the details of the employee, right? Now let us see. Let's run this program. Now we can see clearly, right? So the details of the employee have been displayed. So EMP1 object has its own copy of the employee, which has its properties and methods. So we have taken the data into the object and also called a method using that object, which actually is displaying, which actually executed that method, which called the method and executed the method successfully, right? So this is how we can create an object for a class. So in the same way, can I create like another employee here? Can I create something like this? Is this fine? I already created one employee. Now I wanted to create another employee. So this is all one object, right? Now I wanted to define another object. Can we do this? Now I wanted to define another employee of the same class. Can we do this? Yes. So one class can have multiple objects is what we define, right? Otherwise, there is no point in having a class, right? So we can have multiple objects for a class. So employee 2. I wanted to store employee 2 details. How do we do that? We just need to, again, like assign the values to it. Position, some value, right? So this is the salary and display employee details again. So this this will be employee 2. So what did we do? We created another object for employee class. This is EMP2 is the object name. And using this object, we are actually accessing the data members or properties of the class and then assigning the values to it, right? So we had this properties defined. And then once we define, we are calling this method using the object called EMP2. Yeah, you can see these are the properties of employee 1 and another set has been displayed. These are the properties of employee 2. Likewise, we can create n number of objects per employee, right? And store its properties and also it's optional. We can either call the method or use this object somewhere else, right? So this is how we can define objects for the class. We create a class, right? And we actually declare some properties for it, have some methods within the class, and to use the class we create the object for the class and provide the data like this, and then we can call the methods of that class using the object of that class. So each object will have its own copy, right? So this is one copy, this is another copy like this. So this is copy. It has its own properties and methods if you see. Likewise, EMP2 will have its own properties and methods. Like employee 3 will be another object, its own copy of properties and methods like that. So as it has its own copy, so it needs some, the space will be allocated in memory. Is that clear? All right. let's create, so now you see main method here, right? So this is a class, and we know main method is required to start the execution, right? Meaning like execution starts with the main method. JVM looks for main method wherever the main method is, so it will start execution from that point, right? So now I just want to have this commented it out here. So I'll have only my class definition here in one class, and I'll have my main method written in some other class. Can we do that? Yes, we can do that. So we can have the classes. Usually what happens is like in real time, we define multiple classes. So we define, so if you are working on some project, right? So there will be some modules, multiple modules. Say for example, each module will have multiple classes, but say for example, for now, say for example, there is one class, class one for module one, right? Class two, class three, like that. You'll have multiple classes defined. So you will have multiple classes defined for your project. Say for example, each module have its own class. So you can't have main method in each class, right? So what we do is, so all these classes, we can create objects for all these classes in some other class, classes, right? And we'll have one special class which we can create it for defining, for having the main method. So anyway, even for calling main method also, that we have to do it in a class, right? So this will be our main class, which will have the main method, and then execution starts from here. So we'll have the classes, we'll create the objects wherever required for these classes, but this will be like multiple classes, but the execution has to start from one class, right? So that class, so we'll create one class where we'll drive the execution from. In that class, we'll actually define the main method, and execution start from this method. So this is how we usually write a, classes and create the define the main method in it in real time, right? So we'll have one class where we'll have the main method and start the execution from. Now, so if you see, that's what we wanted to achieve, and if you see, I'm gonna comment this main method here and create a new class. So likewise, say for example, I have multiple classes, and now I'm gonna create a new class for creating a main method. We'll call this as employee main, just to indicate that this class will have the main method. This is like our classic main method, right? Employee emp1. I wanted to create an object now for the employee table, employee class, right? So employee, new employee. So when we say new, so a new object gets created in the memory, and its reference is stored in this emp1 object, right? So now this has created an object. All right. So when we say reference variable, instance variable, so that is what this is. This object can be called as reference variable as well as instance variable, right? But we, but in short, also in short, or usually what we call this as an is this is an object of employee class, right? All right. Now we can provide the details to this object employee one dot employee. So what are we doing here? We are not within the same class employee now. So we came out of that class, we have different class now. And still we are creating an object of employee class, if you observe, right? Now, can we do the like this? Yes, definitely we can do like this. And because you can see here, right? We are not getting any error, right? So we can display the employee details like this as well. So what did we do here? We had a class called employee, and we had a main method in some other class. And within the main method, like we are creating an object for employee. We can do like this because like if you see, it is almost like an or any primitive data type, right? So now we have defined this. This is our custom class. Data type used to be the built-in ones. So we usually had int a equal to string str equal to something, right? In the same way, we are creating an object for the employee class which we created, and we are assigning some values to it and calling the methods within that class, right? So we can do this. This is valid, right? So even like, in fact, this is how we actually do it in the real-time projects. In the real-time projects, we even will have the classes defined and methods, different methods. In within the methods, we actually create the objects, right? So here in the main method, we are creating, right? In the main method, we are creating the objects for the employee class, and then we are actually calling the methods within that class, right? Now, if this employee class is in the same package, so as it is in the same package called day 1, day 10, so you don't need to actually import the statement. We are not writing, if you see here, so if you see, this is the employee class and this is also a class where we are having a main method. So we say that when we execute it, so for example, in the class, right, this is only class. This doesn't have main method, right? So say for example, if you right click on it and do run as, you will not get that run configuration. You can't run this Java application, right? So this is only a class. But when you come to this class and right click and say run as, you will get an application option called Java application, because it has main method, right? So we can only run the program from this class. So within this class, what did we do? We had a main method and we are creating objects within this main method, right? All right. Now we are discussing about the import, right? So if you observe, we didn't import anything like this employee class could be anywhere, right? But we are not importing it. We are not specifying the package, but because this, this employee and employee main, both classes, so both classes are within the same package. Say for example, so this is the reason we are not importing again package data, right? Say for example, this employee main was in some other different package, right? Say for example, it was in some package called special package, right? So in that package, we have to specify where this class employee is, because that class might not be knowing where this employee class resides in. So then we'll provide something like this: package name dot class name. Then, which means that I am referring employee class. That class is in this package. So you can get the definition of that class within this package is what we mention it. And that if this class is a different package, as it is now in this case, both are in the same package. We don't need to import that. Import the, we don't need to write the statement to import this employee class, as both are in same package. But if it is in a different package, we do specify the import statement and we specify the package in which the employee class resides. So is that clear? Okay, hope it is clear and you understood the topic. Now let us see one more example. we'll have a class called student, and student can have its own properties, right? Student can have student ID, student can have student name. It could have marks as well. Now, for now, just I am taking grade. Grade as char, right? Now, I'll have one method. I'll say current student data. Now, how did we did earlier in employee table, in employee class? So we actually displayed the values in each line, right? So can we display all these in one line? Yes, we can do. So what we can do is we'll have it written everything in one line. We can just say student ID, name, grade. Everything we wanted to display in single line. So this is a valid class, right? So class name enclosed in braces, curly braces, and it has its own properties, and it has its own methods, right? So this is a valid class. Now, if you right click and try to run this class, so you'll not get an option as run as Java application because this is just a class, right? So we need to create an object for this class, and then we also need to have a main method. So let's create a main method. So within this main method, I wanted to create an object of student, right? Student is equal to new student. It's case sensitive, right? So this is uppercase. Student is equal to new student. Creates an object of student. So this is an object of student class now. It's been created. Now we wanted to assign ID. We wanted to assign some data to it, right? Something, some name here, this dot grade. Grade is of char type if you observe. And what is a char type? So what data it can hold? Character data type can hold only single character, which is enclosed in single quotes, if you remember, right? Now, if you observe, we get run as Java application option because we are in main method. So this class has a main method. So we get this option called Java application, run as Java application. And you can see this time we are actually displaying the results in single line. So this, what happens? So when we run this main method is like an object for student class is created. The data is assigned. So it has the data. This object S holds the data for the student, like its own copy, and then it is calling its own method. So as this holds the data, and with that data, it is actually calling this method. So it knows the information about these properties as well. So this is about creating the object with a reference variable, right? Say for example, uh, I am having this reference variable, right? Can we do like this? New student. I'll create new student and then new student of dot SID. Say for example, I have something like this. New student dot SNAME. Is this valid? Now finally, what I'll do is why this is written error. All right. New student dot print student data. Can we do like this? This is with the reference object with reference variable, right? Now we are not creating a reference variable, but still we are doing the same thing. If you have the new student, we created and new student dot SID, the same, right? Instead of having the reference variable, we are just replacing that with the new student. Is this valid? So let's run this and verify. So if you see, you get the data as zero null like this, right? So you are not getting this data as expected. This is because, so we are not creating the reference object here. So because, and what is happening here? Let's see. So you said new student, an object gets created and you see new student again, right? So this will be another object. New student will be another object. And for that, you are defining some SID, only SID. And we are actually having new student again, right? So this actually creates another variable. And for that, another object. And for the object, we are defining only HNAME. New student, another object gets created. And for that, we are having only grade, right? So for each object, we are only having one property of it. And also, what are we doing? To print the results, we are creating another object. This is again a brand new object. And for this object, so this object particularly doesn't have any data in on its own, right? But still you are trying to print the data. So it doesn't have any data. So the default values of it are displayed here. So we always needs to have a reference variable to hold the object data. We are creating the objects, but without the reference variable. So like how we are creating, employee or, student, student is equal to new student. What's the meaning of this? So we are creating an object of student class, right? So if you remember, we did like this as well in last sessions, something like this, right? So what does that mean is, so if you observe both seems to be the same, right? So only thing is we are initializing string here, that's fine. But if you see, both seems to be the same, but string is a built-in class in Java, which is present in java.lang package. And we can use this string, we can create object for the string, right? This is how we used to create the object for string, right? In earlier sessions. So now you will get a better understanding. So string, str meaning an object. So new string. So when we say new string, an object of a class string will be created and its reference will be stored in a variable called str, right? So this we are calling it as an object, string object. right? Now, in the same way, what did we do? We created our class. So student, is that a built-in class? No, this is not a built-in class. This is a custom class we created, or we can call this as a user-defined class, which we created and we gave a meaning, like we had some properties and methods within it. We defined it, right? Now, on top of the class, we are creating an object like this. So in the same way, for the built-in classes also, what are all the already predefined classes, we can use those classes by creating the objects for those classes. And how we use this method, right, of this student class, in the same way, if you remember, we used to use the methods of the string, length, caret, like that. So because we, whoever has written this string class, the Java developers, right? So who has written the language specification? So they have actually written the class called string within a package called java.lang, and they define multiple methods within that class, and they have provided some definition to this within those methods, right? Those methods we are using by creating an object for that class. We are actually calling those methods to achieve some particular task, right? So say for example, length. Length actually gives us the length of the string, right? So caret actually gives us the char at that particular index. So whatever index it is pointing to within that string, whatever character is placed is present at that particular index, that particular position, that character will be returned, right? So like that, so we have multiple methods defined in the string class, which we can access it by creating an object for the string class, and we have seen this, right? So now it will be clear for you, like why like why we were creating the objects for calling the methods, right? So because we need an object, so which will be a reference, right? Which will be which will actually is called as a reference variable or instance variable, which will hold an object of it, new object of its own object, and on top, using that object, we can actually call the methods defined within that class, right? So any questions? Are you able to understand this topic? Are you there? Am I audible, guys? Okay, hope I'm audible. You can put your response on the chat. All right. So this is all about a class and object, right? So very important concepts in object-oriented programming, right? So without a class and object, like we can't write any other programs, right? So we define a class, and then for the class is a blueprint, just a blueprint. We create the object for the classes. So which will be the actual physical entities which we can use it, right? So, and we'll discuss, so what did we discuss? Class is a collection of properties and functionalities. So big class properties means attributes which hold the data, and functionalities is methods which actually shows the behavior, which actually represent the behavior of that class, right? Now, yeah, we have seen what the characteristics of class, and have seen the examples for the class, and what is an object. Object is an instance of a class, right? So it's a physical entity, and we have seen some examples on classes, right? Class and object. How do we create a class? Class has properties and methods, and how do we create an object for the classes? We have seen that, and we have understood with the different examples. So we can wrap up this session here. And in the next session, like we'll discuss more on the methods. So if you see here, this methods, so we have just created methods, right? So one method like this, we can have a number of methods defined within a class. And each method, we just took a simple method, which is returning nothing, and also which is not taking any parameters. But you know, the methods can take the parameters and also return some value. It can return the value by not taking any parameters. It can take the parameters, it can return the value like that. It did not return the value, but can take the parameters. We will see all the combinations of methods. So this we call it as signature, and we'll see uh, how we can define like methods, and about the taking parameters within the methods, and all about the methods in the next session. We'll discuss it in detail about the methods. I'm stopping here. If you have any questions, you can ask.